It's the year 2027, and quantum computing has started to move out of research labs and into real-world applications. A decade ago, quantum computers were still experimental devices studied by physicists and computer scientists, trying to harness the strange properties of quantum mechanics. But steady advances in hardware and software have now made practical quantum computers a reality. The watershed moment came in 2022, when IBM unveiled its first commercial quantum computer, intended for business and research applications. Dubbed IBM Q24, it boasted 24 usable quantum bits, qubits, and demonstrated capabilities far beyond classical supercomputers. For certain specialized tasks, IBM made the Q24 available via cloud access to startups and Fortune 500 companies alike. This kickstarted the quantum computing revolution, with other tech giants like Google and Microsoft scrambling to keep up. But it wasn't all smooth sailing at first. Real-world quantum computers are finicky devices. They require advanced cryogenic systems to keep the quantum chip extremely cold, shielding it from vibrations and electromagnetic waves that can cause errors. The quantum bits themselves are fragile. The slightest disturbance can disrupt the mystical quantum effects that give the computer its power. There were plenty of skeptics questioning whether quantum computers would ever be robust and reliable enough for practical use. The pivotal year was 2024, when a small Canadian startup called D-Wave Systems became the first company to sell a commercial quantum annealer. Unlike universal quantum computers, quantum annealers are specialized devices designed for optimization problems. D-Wave's annealer squeezed over 5,000 superconducting qubits onto a chip, allowing it to solve certain complex optimization problems, orders of magnitude faster than conventional computers. Volkswagen became D-Wave's flagship customer, using its quantum annealer for things like optimizing vehicle fleet management and supply chain logistics. This high-profile partnership signaled that quantum computing was ready for prime time. Investment poured into quantum startups from venture capital firms and corporate R&D labs. The quantum gold rush had begun. By 2026, the IPOs of quantum computing companies like Rigetti Computing, iInc., and PsiQuantum were major startup success stories. As revenue from quantum hardware and software started to flow in, new quantum data centers began popping up around the world. Cloud access opened up quantum capabilities to small businesses and researchers. An ecosystem of software tools and applications emerged to allow more people to program quantum computers without needing advanced physics degrees. Now, in 2027, quantum computers with over 50 qubits are commercially available, and systems with over 100 qubits are in the works in research labs. While still modest compared to classical supercomputers with millions of conventional bits, these quantum machines are entering a regime where they can do things no classical computer could possibly accomplish. Drug companies are using quantum computers to analyze chemical compounds and discover new medicines. Engineers are optimizing complex systems like airline schedules and supply chains with quantum algorithms. Machine learning techniques tailored for quantum hardware are leading to breakthroughs in AI. Quantum encryption is securing data and communications in an era of rising cybercrime. Excitement is also building for potential quantum advances in clean energy technologies. Of course, not everything quantum computing promises has come to pass yet. Universal error correction, which would allow more precise qubit control, remains tricky to implement outside the lab, and the killer app that would drive mass adoption of quantum computing has not emerged. But the trend lines point toward continued exponential growth in the power and versatility of quantum information systems. Many experts are hailing this as one of the biggest computing revolutions since the invention of the transistor. Quantum computing will never fully replace classical computers. In fact, the two work together synergistically. But this new paradigm is opening up possibilities that could reshape society and industry. The quantum age has only just begun. With more investment and talent flowing into this space, we may look back in another decade and be amazed by how far these systems have come and what human ingenuity was able to build using the quirky principles of quantum physics. The next generation of quantum discoveries surely holds many more technological marvels in store. Subscribe.